fisheries management practices in the Baltic Sea.
Hello everyone, thank you for listening to me today. Management is based on total allowable catch or TAC quotas, which are based on scientific advice given by scientific bodies such as Thesis and STCF. The problem with the current fisheries management is that it is based on large spatial and temporal scales, and fish as a biological resource varies at much smaller level. Another problem is that mixed fisheries problem. So most TAC quotas are set individually, but in an area where fishermen catch several species together, it might happen that quota of one species is used up before the quota of another, and this might lead to unsustainable exploitation. On top of this, there are fishermen issues. So the current fisheries management is imposing numerous rules and prohibits that might sometimes appear contradictory and sometimes are hard to understand. So to try to solve this problem, a novel management strategy called Realtime Incentives was proposed in 2012. The basis of this management relies on RTI map that represents RTI tariffs for different areas. Such a map will be given to a fisherman along with RTI credits, and then they can decide on their own where and when they want to fish as long as they have RTI credits left. Another important thing about RTI management is that it uses high spatial resolution, and also it is updated with real-time catch information, so it can track fish dynamics better. Also, as you can see this in figure 1, this map is color-coded, which makes it easy to understand. This is a pioneer study on how to implement the RTI management system in a mixed demersal fishery in the Baltic Sea region. This master thesis aims to produce RTI maps at fine spatial and temporal scale and propose how to combine these into one RTI tariff map. It also investigates how effective RTI management would be in the Baltic Sea. So the species that were chosen for this study are cod, which is economically the most important species of the area, and also plaice, which is the second most important species commercially speaking. They both belong to demersal fisheries, and the location that was chosen for this study is FAO subdivisions 22, 24, and 25, and they are marked in red here in the figure 2. My work in the master thesis was divided in two phases. The first phase was exploration phase, where I produced catch per unit effort maps to spot any seasonal variation in catch rates that could occur throughout a year. Also, I produced ratio maps to investigate whether there are areas with high cod and low plaice catches, and also the other way around. This is important in a case where fishermen should target areas where they can avoid the bycatch of one of the species. Also, higher spatial resolution maps were produced to find an optimal spatial resolution for RTI maps. And then an optimal temporal scale needed to be found, and this is because the RTI maps should be updated on weekly or monthly basis. So the second phase was actually RTI Maps Production. I produced single species maps and also combined RTI maps. So with the single species maps, two separate RTI maps were produced for cod and for plaice species or stocks. And then in the combined RTI maps, the tariffs from both single species maps were combined in order to produce one map that would serve for the management of both species together. Also, simulations were run in order to estimate overshoot or undershoot of intended catch levels and to show how effective RTI management is in this region. The data that I had are data from 2014 until 2018, so the catch data. The data from 2014 to 2017 were used in order to produce a base map, and here in the figure 3 you can actually see the base map for cod stocks. So this is the first RTI map that the fishermen would get in the first week of a new management year. And then data from 2018 were used as a new catch information. So based on the data from 2018, the RTI map gets updated. The results. Catch per unit effort maps did not show in catches regarding seasons for cod or for plaice, so the season is not a significant factor that should be taken when producing RTI maps. Next are the ratio maps. So here in this figure 5, you can actually see an example of cod to plaice ratio from 2014. As you can see, the majority of areas are blue, which means that in majority of places cod is strongly dominant. So the blue color represents the places where cod is more abundant, and the red represents places where plaice is more abundant. Overall, 65% of color squares have extreme ratio percentages, and in this case, extreme ratio percentages means that one species is more than 10 times abundant compared to the other. Higher spatial resolution map showed that ICES rectangles are not uniform in fish availability. And here you can see 3 figures. So figure 6 is representing a coarse resolution map, actually the resolution of ICES rectangles. Then figure 7 is the middle resolution, and figure 8 high resolution map. Even though the high resolution map shows the most additional variability, the middle resolution map is chosen as the right approach when producing RTI map, because the middle resolution map is actually manageable, and the high resolution map would be really hard to manage. For the temporal resolution, correlation was performed between catches of the weeks and catches of the months. So the correlation threshold was taken at 0.2, which means that everything bigger than 0.2 is actually positive correlation, and everything smaller than 0.2 is either absence of correlation or negative correlation. The result is that both between months and weeks there is a majority of positive correlation in both stocks. However, there is a higher percentage of positive correlation between weeks in both species. So this is why the weekly update is chosen as the right approach when producing RTI maps in this region. So how the update of RTI maps work. Here in this figure on the left side, you can actually see the catches from week 1, week 2, and week 3 from 2018. So the 2018 is actually taken as the current fishing year. Then on the right side, you can see how RTI map gets updated according to the new information arriving each week. You can see that the catches are actually occurring only close to the German coast in the first 3 weeks, and then the RTI map are updated accordingly only in those regions, and the rest of the map will stay the same. So this is just the example how the update of RTI map would go from week 2 until week 12. And at the first glance, it's really hard to spot the differences, but we can come back to this later to see it more detailedly. So the simulations, this is the result from single species maps, and in figure 11 the graph above is representing the distribution of relative cod catch, and the graph below is distribution of relative plaice catch. So the value of 1 on x-axis is actually showing that the actual catch according to RTI management is equal to intended catch, and this is, so to say, the perfect case. So the majority of cases fall between 0.9 and 1 in both species. Overshooting risk by more than 10% and undershooting risk by more than 20% should be avoided, and the result is that there is only 0.1% of chance to overshoot in cod stocks by 10%. So the simulations for the combined management, the majority of cases here falls between 0.85 and 1 for cod, and between 0.9 and 1 for plaice. Again, overshooting risk by more than 10% is 0 for both stocks, and undershooting risk by more than 20% is only 0.1% for cod. The seasonal pattern in catches or CPUEs shows that the season is not a significant factor. However, that's the result only for this region of the Baltic Sea. This is very case specific, so it might be that the season is a very important factor in stocks somewhere else. We saw through simulations that both combined RTI map and also single species map are are good enough, so to say, for the management. So in a case like this, when the both management approaches are suitable, it is better to go for a combined RTI map, because in the combined RTI map we have information from both stocks, and if we go for single species maps, then it's only management based on one or single species information. Also, the involvement of fishermen is very important aspect of RTI management, and they get more involved with the credits that they get in RTI maps, because they can choose where and when they want to fish. Also, ratio maps showed us that 65% of the area has more than 10 times catches of one species compared to the other. However, already the ratio from 3 to 10 times can be enough to reduce the bycatch. So actually we can say that even more than 65% of the area is potentially suitable for reducing a bycatch of one species. For the spatial and temporal resolution, it is again case-to-case decision. So the results from the Baltic Sea might not apply somewhere else. This is a balance between what's easy to manage and also how much additional variability is accounted. So we saw that in high resolution maps there is much more additional variability compared to ICES, and even more additional variability compared to the middle resolution, but because the cells are so tiny, it will be hard to manage. Both weekly and monthly updates are suitable, but simulations also confirm that updates on weekly basis is better, because if the updates on weekly basis was not suitable, then we would see the distribution of catches wider on the graph. So the simulations outcomes are between 80% and 110% of the intended, which means that RTI management could be successfully implemented in this area. The risk of overshooting and undershooting are a trade-off between economic and conservation goals. So the managers could give higher amount of RTI credits to fishermen so they can fish longer, but then in those cases the risk of overshooting will be bigger. However, if the conservation goals are more important, then the fishermen would get less RTI credits, and then the risk of undershooting would be bigger. However, these simulations are a very simplified approach, and they are not a validation of tariffs represented here. So the managers should take more factors into account when producing RTI maps, RTI tariffs, and when they are running simulations. One of those assumptions is that the middle cell is uniform in fish availability. However, we know that from high resolution maps, the cells are not uniform in catches. So there are fish hotspots within a cell. And then if the fishermen have knowledge of those hotspots, they would go each time to that particular spot in a cell, and then they would always catch more than the RTI tariff is actually predicting.
2 minutes.
Okay. So to conclude, RTI management has the promise to be successfully implemented in the demersal mixed fisheries in the southern Baltic Sea. A combined RTI map is proposed as the optimal solution. Both monthly and weekly approaches have good predispositions. However, weekly is slightly better, and an optimal spatial resolution is the middle one. And in the end, the fishermen should be really involved in the designing of the management system, because if they don't comply to rules, then no management system would be good enough. So thank you for your attention.